Section 10.3 Ellipses. Ellipses has more information to deal with than comparing to parabolas. So an ellipse, as we showed you in 10.1, it looks like this. It's not a circle, but a figure like this, and or could be this way. Could be like opening toward parallel to the x-axis or the y-axis. So let's look at the first one on the left side. So what do we need to know in this? There's a middle point here. If you connect the horizontal line through it and the vertical line, this point I'm gonna call it I. It has coordinates h comma k. It's called the center of the ellipse. Center of the ellipse. And this has A and B. We call them vertices. C and D are called co-vertices. That AB is called the major axis, has two axes. And CD is called the minor axis. Always on the major axis there are 2 points called the foci. Focus is singular. So F1 and F2, those are called foci, F1 and F2. Foci. Now the major axis, see, I is the midpoint. So the AB has a length of 2A and CD has a length of 2B. So this means IB is A and IA is A. IC is B, so this is like BB. Now from I to F1 is CC. So F1, F2 is 2C. The relation between A, B, and C in ellipses is C squared equals A squared minus B squared. Looks like the Pythagorean theorem, but it's not. So C squared is A squared minus B squared all the time. Now, ellipses, they have their own formula. And the formula for the ellipse, it takes a lot of time to prove where that came from, is x minus h squared over a squared plus y minus k squared over b squared equals 1. That's the main equation of the ellipse. So in this case, just so you know, always a is bigger than b in ellipses, because a is on the major axis and b on the minor axis. So that's why a is always bigger than b. These are all the information you need to know about ellipses. HK are the coordinates of the vertex, A and B on the minor and major axis. So always to find the equation of the ellipse, you need to find the vertex A and B. Then you'll be done. Now how do we know if it's going to be parallel to the x-axis or to the y-axis? If the bigger number is below the x-axis, as you can see here, this is the x and A is below it, then we know it's going to open parallel to the x-axis, or it's going to be sketched parallel to the x-axis. If it goes like this, x minus h squared over b squared, y minus k squared over a squared. Then notice where the bigger number, A, again, A is bigger than B, A is below the y, so that's why it would be this one. Then it follows the same way as the other one. So then we draw the two axes, I in the middle, the center, the same thing. Then these are the vertices and these are the co-vertices. And the foci would be always on the major axis. The c squared equal a squared minus b squared works the same in this case as well. The major axis has length 2a, minor axis has length 2b at all times. A always bigger than b. So that's how we work with conics here. So let's say I'm gonna analyze an equation. Let's say x minus 1 squared over 25 plus y plus 2 squared over 9 equals 1. So notice how the bigger number first is below the x. So I know it's going to be structured parallel to the x-axis. So a squared is 25 and b squared is 9. From these two I can get c squared right away. which is a squared minus b squared. And that's a 25 minus 9, that gives me 16. So from each one, I find a. A is 5, because that's a distance. I don't care about the negative, so c is 4. And from here, I can find the center of the ellipse. It's 1 comma negative 2, if you can compare this to the given equation right above it. 1 comma negative 2, h and k. From here on, always, if I want to find the rest, I don't memorize any formulas. I just plot the given, and I get everything from there. Center is 1, negative 2. That's the center. And remember, it's going to be parallel to the x-axis here. A is 5, so we're going to move to the right 5 units. 1, 2, 3, 4, 5. So that's going to be at 6. So that's one of the vertices. 1, 2, 3, 4, 5. That's going to be at negative 4. That's B, AB. And B was 3, so you're going to go up 1, 2, and 3. That's C. Down 3, 1, 2, and 3. That's D. So we can kind of like rough sketch the ellipse. See how it looks like. That's the ellipse. From here I can find everything we need. So we got the center, vertices. Vertices A is 6 comma negative 2 and B negative 4 negative 2. Co-vertices C is 1 1, D 1. Let me see, what was this? We moved down 3 units, so 3 units from 1, 2, and 3. So negative 3, negative 4, negative 5. Negative 5. Those are the co-vertices. Now we can find the major axis. Major axis has a length of 2a. 2 times a was 5, 10. We can find the minor axis. The length of the minor axis is 2b. So 2 times 3, which is 6. We need the foci, F1. So we need to go, C was 4, so you're going to 1, 2, 3, 4. So it's here, that's F1. So F1 has coordinates 5, negative 2. And F2, you have to go 1, 2, 3, 4. That's a negative 3 comma negative 2. So we found the foci. What else we need? So we found the center, we found the vertices, co-vertices, the length of the major axis, length of the minor axis, the foci, and then we graph the ellipse. So nothing else can be found here. So that's everything we need. Do you see how as soon as you find A, B, C, and the center, then you can plot those on the XY plane, and then from there find everything you need. Let's look at another example. Same thing, analyze the ellipse with equation like so. This one is not written as something square plus something square, equals 1. What we need to do is complete the square. On the x squared, there's no x term, so x squared stays the same. For the y's, we factored the 3 out, so that gives us y squared minus 4y plus the 9 stays the same. So completing the square will happen or occur inside the brackets. So what do? We take this number here, divided by 2, you get 2, and square it, you get 4. So we're going to add 4 always and subtract 4. That's the trick. Then the underlined part will be written as y minus 2 squared. That's completing the square. Minus 4 plus 9 equals 0. So now keep this the same. 3 times y minus 2 squared minus 12 plus 9 equals 0. I multiplied 3 by the whole factor and 3 times 4. Keep this the same, this the same. That's a minus 3 equals 0. So then keep this the same, add 3 to both sides. divide everything by 3. X squared over 3 plus y minus 2 squared over 1 equals 1. Why did I divide by 3? I need to make sure the number on the right side is 1. So now, what's the center here? The center of the ellipse is 0, 2. And notice a squared is the one below the x, so we know the ellipse is going to be parallel to the x-axis. B squared is 1, is this number. From these two we get c squared, which is a squared minus b squared. So a is the square root of 3, b is 1, c is the square root of 2. So I got a, b, and c. We have the center, a, b, and c. We can plot them on the graph and get everything we need. So let's look at this. Center 0, 2. That's the center. I. Right? Let's label in black. I. And we have, remember it's parallel to the x-axis. So we're going to go 1, 2, 3, like just label the axes. So it means to the right, I'm going to go root 3, which is a little bit more than 1 or more than 1.5. And this way, root 3. Up is 1, down 1. So it's going to look like this. A, B, C, D. So we get the center. The vertices. A has coordinates square root of 3, 2. And B negative square root of 3, 2. We have co-vertices. Co-vertices. C is 0, 1, 2, 3. And D 0, 1. C and D. We got the vertices, co-vertices. The major axis has a length 2a, which is 2 square root of 3. Minor axis has a length of 2b, 2 times 1, 2. And what is c here? C is the distance from, if you connect this, so whatever we pick here, that's f1, that's f2, that's c, from here to here or from here to here, square root of 2. So then the foci, that will give me the foci. F1 is square root of 2, 2, and F2 is negative square root of 2, 2. Vertices, co-vertices, foci, major axis, minor axis, and we graphed it, and we have its equation. That's what we did in the previous one as well. We found all the same information. Right? So now let's look at how we find the equation of the ellipse with given information. Center 0, 0, let's say. Focus negative 1, 0. Vertex 3, 0. So that's the first example of finding equation of an ellipse. Always plot the given, the key. 0, 0 here, that's the center. Negative 1, 0, the focus. Vertex 3, 0. 1, 2, 3. Call it A. So this tells me if the focus and the vertex here, so it's gonna look like this, right? Because always the vertices and the foci on the major axis, it's gonna be parallel to the x-axis, and so that tells me the equation is gonna go x minus h squared over a squared. So a must be below x. Y minus k squared over b squared equals 1. Remember, we need h, k, a, and b. h, k is already given here. They give it to us. Now we need a and b. The distance from the center to the vertex is a. So I know A here. A is 3 units. B is the distance from the center to that point, but I don't know what that point is. They give us one more piece of information that we can use from here to here. That's a C distance. So I have A and C. So C is 1 unit and A is 3. We have C squared equals A squared minus B squared. 1 equals 9 minus B squared. So B squared is 8. That's what I need. I need B squared. B squared is 8. So then from the equation, x minus h is 0 square, a squared is 9, y minus 0 square, b squared is 8 equals 1. So that gives us x squared over 9 plus y squared over 8 equals 1. That's the equation we're looking for. Let's look at a slightly different example. Let's say they give us the foci at 0 plus or minus 2 and the length of the major axis is 8. Length of major axis is 8. So again, plot the given. 0, 2, that's one of the foci. Negative 2 is the other foci. So this tells us that the ellipse is going to be parallel to the y-axis. Parallel to the y-axis, like so. So this tells me that the equation is going to be x minus h squared over b squared, not a. And y minus k squared over a squared equals 1. So what can I get out of this? Let's see. Always the vertex halfway, the center halfway between the foci or the vertices or co-vertices. So it's going to be here at 0, 0. That's the midpoint between f1 and f2. So I already know this is 0 and this is 0. They give me the length of the major axis, which is 2a. It's 8. So a is 4. I found a. They also, from this given, from here to here, that's c. c is 2. We use c squared equals a squared minus b squared. 2 squared is 4 squared minus b squared. 4 equals 16 minus b squared. Solve for b squared. B squared is 12. Now, x minus 0 squared over 12. Y minus 0 squared over 4 squared, 16. So the final answer is x squared over 12. Y squared over 16 equals 1. Now, let's look at another example. Let's say they give us the vertices 2, 5 and 2, negative 1, and also they give me the value of c. The best way to get everything you need here is plot the given. 2, 5. Let's call it A. B, 2, negative 1. That's B. So this tells me that, oops, sorry, I thought those are the foci. This tells us that the ellipse is going to be parallel to the y-axis. It's going to be parallel to the y-axis. So it's going to be like that. 0, negative 1, 1, 2, 3, 4, 5. So halfway between those, maybe here. Yes, that point. 2, comma 2, that's the center. So the center right away, 2, comma 2. I need this all the time because that gives me h and k. Now the distance from the center to there, that's A, which is 1, 2, 3 units. So A is 3 units. They give me C 2 units. I can get B squared from here. 2 squared is 3 squared minus B squared. 4 equals 9 minus B squared. So B squared is 5. Then x minus h squared over B squared plus y minus k squared over A squared equals 1. So x minus the center at 2, 2, so h is 2, and k is 2. b squared is 5. a squared is 9 equals 1. You don't have to expand. You can just leave it like that. So no matter how they change, if they give you foci, the two foci and the vertex, or if they give you vertices and something else, or they give you a center vertex and contains a point, or if they give you a center, focus, and vertex, they all follow the same method. They all go with the same way. Is plot the given, see what is given, what can you get out of it, and then from there find this A, B, and the center. Center means H and K. A, B, and center. That's all you need, A, B, and the center. And this formula that I wrote here, this helps a lot. Most of the time they either give you A or B and C, and they ask you, you use it to find. If they give you A and C, you get B, or B and C, you get A, because at the end you need both A and B to be able to use it here. So this is very important stuff to see how we can use the graph to do it. If you don't plot on the graph, it's going to be difficult to see it, visualize where to start, where to end, how am I going to solve this. Yeah, that's why I plot the given on the XY plane, and then from there I can see how much information I can get out of it. Again, keep in mind, center is the midpoint between the vertices, the foci, and the co-vertices. That's which is point I. So I is always halfway between the vertices, co-vertices, and the foci. That helps. A is the distance from the center to the vertex or the vertices. B is the distance from the center to the co-vertex. C is the distance from the center to the foci. Those are important terms to know.